Good evening guys, welcome back to another interesting video of Success Tracker. Some questions of curiosity and the strange answers to which that will let us have been discussed in the previous video. In this video, we are calling your attention to a somewhat vividly weird question. Why can't I dig a hole to the other surface of Earth? Here is the answer guys. Earth is a sphere and we can reach the exact place of our commencement by traversing around the world without U-turns, provided having a compass. Then it seems like it should be a simple task. Dig deeply enough straight down and you should strike sunlight on the other side of the planet. But it's obvious somehow that we can't reach the other surface by digging through Earth. Despite knowing the fact that, shall we go on a voyage digging down the Earth's surface by confronting the obstacles awaiting us? Come guys, let's go to the matter. Let's discuss the obstacle number 1, Earth's crust. High or low, wherever you go on the planet, you are traveling on or above the Earth's crust. Our planet's outer layer began taking shape 4.5 billion years ago atop the fireball of asteroids, comets, and other space debris that clumped into a gooey lump to form Earth. As the surface cooled and hardened, Earth's crust was formed. It comes in two types. When you reach down and feel the ground, you are touching continental crust. It ranges from 6 miles to up to 47 miles, deep under Mount Everest, Earth's tallest mountain. Continental crust consists of less dense and much older rock than oceanic crust. Next one is oceanic crust. It is about 4 miles thick at the bottom of the deepest ocean trenches. It's still taking shape in these mid-ocean ridges where molten rock erupts form in the ocean floor and cools to form new crust. Have you any conception that neither crust seems particularly thick? Tell that to the geologists and mining companies that you tried digging through it. Despite using mid-ocean ridges as a starting point for digging operations, they haven't been able to pierce the crust. Take that, it's too tough, fiercely hot, and full of hazards, from pockets of molten rock to lakes of boiling sulfur. Let's move on to the second obstacle, that is the mantle. Even if you manage to dig through the Earth's crust, you have literally only scratched the surface of the planet. Below lies the mantle, a layer of semi-molten metals such as iron, magnesium, and aluminium. The heat and pressure here are intense enough to compress carbon to diamonds, the hardest natural material on Earth. The easiest way to reach the mantle is to ride the oceanic crust. Once it reaches the mantle, oceanic crust melts and returns to the surface as magma in ocean ridges, when it recycles into new crust. The whole process takes about 200 million years. And now, again approaching to the coast, there is another obstacle, that is obstacle number 3, the outer and inner cores. It is a spherical mass-sized sea of molten iron and nickel swirls about 1800 miles beneath your feet. It flows around an inner core of iron 2 times the size of Moon. This flow of liquid iron around the solid inner core creates the Earth's magnetic field. Temperatures in the inner core exceeds 10,000 degrees Fahrenheit, hotter than the surface of the Sun. Yet the intense pressure here locks the molten into a solid sphere. Good luck guys for digging through that. The next one is the big squeeze, that is obstacle number 4. The deeper you dig into Earth, the deeper your troubles was. Gravity puts trillions and trillions of tons of metals, rocks towards the planet's center, and the weight of all the rough stuff above your head increases as you dig. Suppose nothing less but holding the whole Earth from its very center. The pressure in the inner core is 3.5 million times the air pressure you feel on the planet's surface. Kindly keep in your mind that Your body would suffer serious damage once you hit 27 times the surface pressure. So 3.5 million gives you a splendid feast. The last and final one is obstacle number 5, tug of war. If not for the pressure it creates around you, gravity would be your best buddy during the long haul to the center of the earth. It's all downhill to Earth's inner core, after all, and you will actually experience zero gravity at the exact center of the planet. The vast mass of all that molten metal and rock around you pulls you in all directions and cancels gravity's effect. Be glorious to reach the center of the earth, but you have only made it halfway point. Your target is the sight of the sun from the other surface. For this, you must repeat all the backbreaking physics-defying work that got you here, except now gravity is working against you. A front turn for it, isn't it? It's time to begin the uphill battle to dig your exit tunnel through the opposite half of the planet. That's roughly about 6,370 km of molten metal and solid rock you will need to dig through. All of it bouncing off your head as you climb up, up and up towards the planet's surface. Also, there's no guarantee for the sun to catch your side, because for 2/3 of the earth is ocean and you have more probability to encounter the deep blue water while reaching the surface. Finally, how was the ease of the journey? So guys, hereby you shall have the clear picture of what all are rattling deep under the surface we place our foot. You can put each step courageously that the earth that holds you have a very dense foundation inside. Click the like button below if you like the video. And don't forget to subscribe the channel and press the bell icon for getting notification of our latest videos. Also, share the video and add your valuable comments in the comment box. Thank you for supporting us.